Thank you very much, Merlin. It's good to see all of you, and I especially want to thank all you speakers for accepting our offer to be a participant in our conference. Appreciate that very much. So we have a real treat to start off the program today. Professor Sir Charles Godfray, who prefers to be known as Charles, is our leadoff speaker. And I first learned about Charles when I found this article in Science Magazine, the premier science journal, and the title of the article, Food Security, the Challenge of Feeding 9 Billion People. And I read that article and said, oh, I wonder if there's a possibility of having Dr. Godfray come and speak at our summit. And I sent him an email, and lo and behold, he said, sure, I can be there. And that made my day and made the day of our NANP committee. So I'd like to introduce him briefly to you, and then we can enjoy his presentation. He's, as he described to us at dinner last night, he's basically an entomologist, but more broadly, he's a population biologist with a broad interest in science. He's the Hope Professor of Zoology at Jesus College in Oxford, a director of the Oxford Martin Program for the Future of Food. He was educated at Millfield and St. Peter's College in Oxford, got his PhD degree in community ecology from Imperial College in London. Postdoc at Imperial College until 2 years until 1985. He returned to Oxford and to Imperial College again from 87 to 2006, and then in 2006 he returned to Oxford College to his current position. He's quite interested in food security, how we're going to feed the world. He's studied malaria. He's had quite a variety of interesting research topics over the years. He's received all kinds of awards, just to name a few. 1994 Scientific Medal, 2009 the Frick Medal of Zoological Society of London. In 2001 he became a Fellow of the Royal Society, which is a very prestigious honor. 2011 he's Commander of Order of the British Empire. And in 2017 he was knighted for his service to scientific research and scientific advice to the government of Britain. His title for today, as in the program, is Health, Sustainability, and Equitability, the Challenges for Animal-Sourced Foods in the 21st Century. Let's give a warm welcome to Charles Godfray as our leadoff speaker today. Wonderful.
Thanks very much, Don, for a far too overkind introduction. And thank you and Merlin for the invitation to be here. A wonderful Washington spring week, and thank you for looking after me. I confess I stand before you slightly nervous for several reasons. One is I'm going to be talking about things where most of you in the room have infinite more knowledge about issues, so please forgive me if I'm a bit superficial about things. I also stand here rather nervously because my country is going through a collective political nervous breakdown at the moment, and why you would want to ask a Brit anything right at the moment, I don't really know. So what I'm going to do in this talk is I'm going to start at some really high-level issues. So what I see as some of the food system challenges over the next couple of decades. I'm then going to switch for the second part into talking a little bit about some of the modeling of the food system that we have been doing in Oxford and with colleagues, especially here in Washington at the International Food Policy Research Institute. And again, starting with a broad question, then looking at some issues around animal source foods. And then the last third of the talk, I want to look at some of the challenges around meat, and I've put some of them up there now. And I'm not going to pretend to come up with any grand conclusions or answers to these challenges, but hopefully stimulate some discussion and some questions. So let me begin with some of the broad issues. And as Don said, my academic speciality is population dynamics, and population biology, both theory and experimentalist. And I do love insects, I have to say. If an animal doesn't have 6 legs, then it's 6 legs good, as Orwell nearly said. But the founder of my field was Thomas Malthus, incidentally one of the sort of founders of economics as well. And it was Malthus who first sort of encapsulated the challenge for feeding the world. And Malthus, in his famous 1798 essay on the Principle of Population, a rather pessimistic take at a time of rather of global optimism. And his argument was the power of, well, there's a quote there, the power of population is indefinitely greater than the power in the earth to produce subsistence for man. He was the first one really to realize the capacity of populations to increase. Populations increase geometrically, 2, 4, 8, 16, whereas food production, he argued, is based on the land, would increase arithmetically. He's very pessimistic. Even if you can feed people now, they'll only go and produce more offspring. So he was arguing that by the early 19th century, there would be widespread famines throughout Europe. And this didn't happen. And it didn't happen largely because of the Industrial Revolution, the complex technological and sociological revolution that took place starting in the United Kingdom from about the 1780s. In parenthesis, I'd say there were famines, of which the Irish potato famine was the worst, but that was a political famine rather than an incapacity to produce enough food. So I'm going to say there have been 3 waves of Malthusian pessimism about our ability to feed the world. And the first one was this one at the end of the 18th century. The second one, I'm just about old enough to remember. And this was around the 60s and 70s, associated with my fellow entomologist, Paul Ehrlich, the population bomb, the Club of Rome, the worry that there was around the 60s and 70s when the capacity of global population growth became apparent, that there would be famine before the end of the 20th century. I reread The Population Bomb. I read it first when I was 18. It had a huge effect on me. I reread it a couple of years back for a radio program in the UK. It's an astounding book, reading it with modern eyes. Looking back, he was advocating coercive population control. And of course, he was really worried. But what he didn't realize was that the Green Revolution was knocking at that door. The extraordinary increase in productivity, largely among arable, but a little bit among livestock as well. Very interestingly, due to a relatively small number of genetic mutations that allowed us to have much more high-yielding wheat and rice dwarf varieties. And so the second wave of Malthusian pessimism didn't come about because of the Green Revolution. And I find this an extraordinary graph here. So if you look at what's happened over the last 60 years or so, the global area in agriculture has increased very slightly, and crop production has managed to stay ahead of population. So that, and again, we do have famines and things like that, but they're largely political famines. It's interesting that of all the Millennium Development Goals, the one that we actually met was the one around hunger. And of course, one of the concomitants of the Green Revolution, which we're facing today, and I'll talk a bit about later on, is that the input going into arable farming really increased, and there's fertilizer use there. And that, again, very positive in terms of crop production, but with major economic ramifications. So the third wave is relatively recently. So the graph on the right is the FAO Food Price Index. And I give both nominal and deflated, because deflated is taking into account inflation and nominal isn't. Now, when they do this, they use US inflation figures, which actually makes sense, certainly in the US and in Europe, but actually makes less sense if you're a poor farmer in sub-Saharan Africa. And the reality, the food prices you experience, especially in sub-Saharan, is somewhere between nominal and deflated. So I've also put US corn prices for the last century up there. And you can see there have been really massive fluctuations in corn prices over the last century, especially around the world wars and the oil crisis. But there was a 50-year period of fairly constant food prices from about the 1970s oil crisis. So the hike in food prices in 2008 and 2010 really became quite a wake-up call. And I think in the States, certainly in Europe, food, which had really not been on the political agenda, came back on the political agenda. And even though food prices have dropped back, although interestingly not quite to the pre-2008 levels, certainly in Europe, and I think especially thinking about development economics, food is really back on the political agenda. Now, I mentioned I was a population biologist and sort of a child of Malthus and hugely influenced by Malthusian arguments such as Ehrlich's population bomb. And I think one of the most extraordinary things that's happened in my adult intellectual life is the demographic transition, the deceleration of population growth that happens if you do certain things. If you bring people out of poverty, if you provide them with reproductive health care, if you educate their kids, especially their girls, then fecundity, the number of children you have, goes down. And they're a couple of years old now, but the UN Population Division world population projections suggest that this century we will see a plateauing of human populations. We did not know this 30 or 40 years ago when I was a student. I like to tell my students in Oxford, I'm more optimistic age 60 than when I was their age. To be crude about it, I think it is game on. Even with climate change, I'm more optimistic now. It is possible intellectually to conceive of a time when humanity's footprint on the environment is going to plateau and even go down. Now, without in any sense saying underestimating what are the challenges ahead, especially around food, I find this hugely exciting, and it's a really interesting time to be talking about food. Now, after being very optimistic, one of the reasons why population is decelerating is people are getting wealthier, which is a really good thing. We want people to come out of poverty. But of course, people who come out of poverty want to have richer diets, better diets, the diets we enjoy in the rich world. And of course, one of the elements of that is that they want to eat more meat. And so this is just using FAO figures about current increases in meat consumption, pretty constant in North America and Europe, but you can see it rising in China. And the inset graph there is the trend at the moment, business as usual, going ahead. And I don't think that will happen, but that's the trend at the moment going ahead. And it is going to be really difficult to feed the whole world if we have that amount of meat going ahead. And that's one of the things I want to come back with. So those are some of the sort of demand side challenges. I'm going to talk very little about this because you will know all this about some of the supply side challenges. Water scarcity, and look at the west of North America there. We're seeing increasing competition for water, and we're seeing increasing problems with our soils. This is a map, again, produced by the FAO of soil degradation. So we have some very major challenges on the supply side, just as we have very major challenges of increasing demand. So that's the end of the first part of the talk, where I sort of skated over some of the challenges. And I did it quite quickly. I'm sure you've been to too many talks which are all about the challenges going ahead. A friend of mine refers to it as the pornography of doom. So anyway, that's the sort of doom and gloom part of the talk. But let me just summarize some of the challenges, some of which I've not talked about in any detail. So we have the continuing demand growth. Something that I'd be really happy to talk about in the breaks and things is I think we do not realize how the world is changing in where we live. I don't know about you, but I still sort of think of Africa as a rural place. Africa is now increasingly urban. More and more, if you exclude China, the biggest cities in the world are now in Africa. that is going to have really major effects on global food system and global food dynamics. I've talked a bit about hunger, so there is good news on hunger. Hunger is actually going up right at the moment, but that's actually due to civil strife and war. We have the capacity, at least at the moment, to feed each other. We're still struggling with undernutrition. So a country like India, which has done wonderful things in reducing calorie hunger, still struggling with undernutrition, largely because some of the issues around the WASH agenda, the water and sanitation, really complex there. And then, well, I was talking about the demographic transition being one of the most extraordinary things that's happened in my adult life. The other extraordinary thing, and I suck my belly in as I say this now, is the obesity crisis. I mean, where did that come from? I mean, it is frightening. You walk around a big city such as Washington or London, and it's the lower socioeconomic groups as well. You know, the poor people who suffer most from this. This is a healthcare time bomb, to use a cliched term. And then I've talked a bit about some of the pressures on agriculture. And the last thing is just resilience to shocks. I'm not going to be talking a lot about climate change here, but that is a real issue. And then finally, it's human shocks. And this is something that worries me, particularly worries me coming from Brexit Britain at the moment, our capacity in a really complex political environment to make sensible decisions about globalized food systems. And again, within the States, with the issues around trade tariffs and trade restrictions, I worry about resilience to human-induced shocks as well as resilience to climate shocks. Okay, so let me go into the second part, and I'm going to talk now for quite briefly about some of the modeling that we've done. I'm going to talk about none of the details of the modeling, beyond saying that we've developed a series of models that link together, an economic model, which is actually developed here in Washington by the International Food Policy Research Institute, to which we in Oxford have added both environmental and health modules. So one can take the economic model, can produce a diet vector. We can use that diet vector to say things about mortality and morbidity and to say things about environmental outcomes. And we're trying to move a bit towards some of the economic consequences. And so blue there is Washington, purple is Oxford, and the yellow are the sort of external drivers that we, the exogenous drivers that push the model. The characters at the bottom are the people who do it, and I would in particular mention Marco Springman and Daniel Mason de Cruz, who are the very smart young people who do all the work, while aged people like me get up and talk about it. So I'm going to ask two questions of the models, and again, forgive me, I'll talk very little about the details or the assumptions, but do challenge me in questions or at the break. And the first is, what if we eat healthily? So what if we actually take the WHO nutritional guidelines if we take them and then we apply them? So let's say that by 2050, we are eating as the WHO want us to do. And we do that in quite a sophisticated way. So we assume that the healthy diets that you eat here are not the same as will be eaten in, say, South Africa or Japan. So there is some sort of sensible regional granularity there. And then let's work out what are the diet-related disease deaths. So again, we run the economics and then we predict the mortality and morbidity. And then let's look at one environmental output, and that's greenhouse gas emissions. And we're trying to actually program in some more environmental outputs. The greenhouse gas is the relatively easy one to do because a molecule of carbon dioxide released here is the same as released in Europe, for example. And then I'm going to briefly say we're going to begin to explore some economics. And so I'm going to show you a couple of maps. I asked the British government for a map of the world that I could use. And then you notice that the UK is in a rather funny position there. So we moved it back to where it should be. And these are some of the results we get. So compared to business as usual diet predictions, then if we adopted a healthy diet, so how many avoided deaths would there be? So again, we all have to die, But how many fewer diet-related deaths would there be if we switched to eating healthily? And the figure we get, and again, please assume there are standard errors around this and lots of caveats, but is of the order of 5 million people. So what does that actually mean? Well, Don mentioned that in another part of my work. I work on malaria. Malaria is the single most important infectious disease for humans. And there is about 500,000 deaths a year from that. Now, I say this with respect to the huge number of people who suffer from it, but we're talking about 10 times more deaths than the worst infectious disease. Now, of course, you know that that's not completely fair comparison because malaria tends to kill younger people than diet-related diseases. But that gives you some ballpark estimate of the goal out there if we can get our public health nutritional guidelines right. So if we were to eat healthily, there's a really big health benefit. Now, the really interesting thing is there is a very big environmental benefit as well. So business as usual, we expect the food system to produce about 50% more greenhouse gases by the middle of the century. If we switched towards eating healthily, then that increase would go down to about 7%. Now, actually, we need to do much better than that. But that's before you do all the interesting mitigation effects that I think we're going to be hearing, including some of the stuff we're going to be hearing about later today. So simply by diet change, you can make really quite a big difference. And I'd also make a point there, I don't know if you can see it, but the lighter orange. Do you think we could turn the lights off here? Is that possible at the back, just to get the, can you see these slides okay? Thank you, sorry to be disruptive. The orangey countries in sub-Saharan Africa are the countries that we actually, I think that's great, yes, are the countries which we actually, well, want is the right word, but we should allow them to produce more greenhouse gases associated with the with food production. We cannot, in the rich world, demand people who still have inadequate diets to reduce their carbon output from food. So with that strong caveat that in developing countries, we should expect there to be some food production associated increases in greenhouse gases. You can still make a big difference. So the lesson from this modeling is a tremendous co-benefit between health and this one environmental output there. And we're working at the moment on some of the other environmental outputs, including water, including biodiversity. And I think the picture will be similar there as well. And here, and I put this up as some very preliminary work, is there also significant economic benefits as well. Now, we're trying to do this economics in different ways. On the left, you will see the economic benefits in terms of reduced carbon emissions. If you take what economists call the social cost of carbon, and the histogram on the right is the direct avoided healthcare costs and the indirect effects, which is the indirect effects you get because people are not off work. So again, one's talking there, and again, huge error bars here, of benefits per year of the order of $0.5 to $1 trillion US. And again, to give you some framing, the GDP of the world, or GWP, is about 80 trillion US. And then the curve on the right, the histogram on the right, which I wouldn't want to defend in any great detail, is what happens if you ask people, how much would you pay for an extra 2 years of life? What economists call hedonic measures of well-being in things. And if you actually ask that, and then you turn the economic handle to get some figures out, you're getting figures which I frankly don't believe that getting on to 15% of global GDP would be saved by better diets. And again, I wouldn't want to defend them, but I think the strong message here is you have a really great economic as well as environmental as well as health benefit of diets. And I think the policy message from this is that we have to talk about diets more seriously. And this is difficult in this country, it's difficult in my country. Politicians don't want to be seen to be, we use the expression nanny state. I don't know if that's used in the States as well. But we do need to have a much more of a discussion about diets. The second question I want to ask of the modeling is around this concept of planetary boundaries. And planetary boundaries, which are associated, don't worry about the words there, I know you can't read it. Planetary boundaries are associated with a number of people, and especially a very talented environmentalist from Sweden called Johan Rockström. And what Johan argues is that there are, I'm going to say what these are in a second, that there are a variety of different dimensions which humans are pushing on. So for example, let me take climate change there. Then you start off pre-industrial, pre-humans at a state here, and we are now pushing climate change beyond this black line. Now, Johan sort of refers to this as a planetary boundary. This is nitrogen pollution. We've pushed it way beyond it. Now, I suspect many of you, especially quantitative people, will have reservations about taking an approach like this. Is there really a fixed boundary? Is it much more a gradation? But nevertheless, planetary boundaries are a really useful way of engaging attention of policymakers. And I think you can do it in a very appropriate way if you put the right caveats around. Now, the team that I'm part of in Oxford did some modeling for a project called the Eat Lancet Commission on Diets Going Ahead. And what we did is we looked at a series of planetary boundaries that are most affected by agriculture. So climate change through greenhouse gas emissions, land use obviously is a major effect of agriculture, water use, and nitrogen and phosphorus pollution. And what we did, and the next graph is going to look a bit complex, and don't worry because I'm not going to go through it in detail. What we did, actually, might it be possible to close this blind without it being hugely, is there a button that can be pressed or? You don't want me to do it because I'll just pull it down or something. If this is difficult, don't worry. Ah, brilliant. The National Academy of Engineering is in this building, so it should work. Thank you very much for doing that. So let me just take the top one, which is greenhouse gas emissions. What this bar here shows is that the different agricultural sectors that make up the impact of agriculture on greenhouse gas emissions now, and we've put it at 100 for today, and what will happen in 2050. And then we've done it for the other land use, fresh water, and so on down there. And I want you to look at the red bars at the moment. The red bars is livestock. The yellows is sort of broadacre arable crops, and then there's fruit and vegetable and something, and other things there. So if we concentrate just in this talk on livestock, then you can see that the biggest effect of livestock is on greenhouse gas emissions there. So at least of the planetary boundaries we've looked. Livestock has effects on all the other ones as well. For example, that's fresh water there, it's got a little bit of use, more on crop land use, largely growing feed. But the big one for livestock affecting the planetary boundaries is through greenhouse gases. So this is looking at the challenges ahead. Then what we also did is, well, how would you actually try and reduce them? And what are the different options that you have to change the food system so it has less effect on these planetary boundaries here? And we did this by looking at 4 different strategies, one of which I'm not going to talk about, which is socioeconomic change, one of which is diets, and in particular, not becoming vegetarian, but going to a sort of more flexitarian diet, which has less meat in it, technological increase, and then waste and lost. And I won't say much on waste and lost here, but you can see that if you are serious about the food system making a positive effect on these different planetary boundaries, these are the things you're going to have to do. Actually, for greenhouse gas emissions, the biggie is diet change, which means, I'm afraid, eating less meat. For most of the others, then diet change can make a contribution. But what we call Tech Plus makes a difference as well. Sorry, there should be pluses throughout there. And what we have assumed here is that the technological improvement, the improvements in productivity are twice the trend at the moment. And we believe this can be done because of wonderful work out of Purdue and other places doing the econometric analysis of the relationship between investment in agriculture and productivity increases. So I think there are two policy messages I draw from this type of analysis, even with all the caveats that I don't have time to go through in detail, that we do need to talk about diet change, especially when it comes to greenhouse gas emissions, and we need to invest more in technological research because we are pretty certain that if we address more in technological research in agronomy, agriculture, across the whole board, but especially in entomology, of course, then we're likely to get greater increases in productivity. Okay, so that's the second modeling, slightly solipsistic part of the talk where I was talking about research from Oxford. In the final part of the talk, I want to talk about some of the challenges around meat that we're going to have to grapple with. And the first is the health challenge. Now, I don't know in the States, but in the UK, there is a lot of argument at the moment that meat is unhealthy, especially around issues such as fat and such. Now, one of the privileges of being in Oxford is that we have actually one of the foremost, and I can be nice about them because nothing to do with my own research, foremost epidemiological groups trying to look at the evidence underlying how different diet components affects disease and mortality. And they do this by using huge, great longitudinal studies, the biggest now having 500,000 people in. And when they look at that, then you can get some indications about meat having an effect on health, but in an interesting way, they're not very strong. So let me give you the strongest effect that meat and health. And this is the effect that eating processed meat, and especially red meat, has on colorectal cancer. Now, I'm just going to, in this talk, concentrate on one thing, and this is the consumption of red and processed meat. So that's the grams today. And this is a sort of meta-analysis. And you do get a significant effect. So if you eat a lot of processed meat, your risk of colorectal cancer goes up. Now, here's a really interesting, at least to me, a really interesting paradox. If you take these numbers and actually turn them into something that everyone can understand, that if you are a young man or woman, I'll talk about men, the statistics are slightly different between the gender, but it's not that different. If you're a young man, your risk of getting colorectal cancer if you eat relatively little red meat is 1 in 21. Now, if you then eat 75 grams of sausages and bacon a day, which is quite a lot, then yes, you're at higher risk, but your chances of getting colorectal cancer go from 1 in 21 to 1 in 18. Now, if you love bacon, that's not a huge difference. You know, I drink alcohol. I hope not too much. I can say that because my wife isn't here. But I'm dealing with much bigger risks than that. So when it comes to your personal effect on health, it's not very much. Now, suppose it's not you making an individual, but you're the Secretary of State for Health here. Then you're talking about hundreds of thousands of people. So there's this curious relationship between relatively small changes in individual risk, which actually at the population level makes quite a big difference in the number of people getting this horrible disease. So exactly how that plays out in the sort of personal and public spheres is very complex. I think one of the issues at the moment is there is so much misinformation about meat out there. Now, I'm putting this up because this was published last week, and it's the Global Burden of Disease study out of Seattle, and this is one of the really best studies. And I've not gone through this in great detail, but if you look at high processed meat, low milk, high red meat, look at these effects here. So compared with diets low in whole grains, diets low in fruit, diets low in nuts and seeds, these make a big difference to your health. When we get down here to meat, sort of low milk is bad, high processed meat, high meat, makes a very small difference. Now, it's a bit complex. The number one risk there is sodium. And as I've not been through the statistics, I think that the effect of sodium in processed meat probably comes there. So it's a bit more complicated. But the point I'm getting across here is there is an effect of eating meat and animal-sourced food on your health. It is relatively small, and there's a lot of misinformation out there in the literature. So that's, I think, one of the challenges looking ahead around meat. The second is meat in the environment. And here, and again, going back to some of the results that I showed you earlier, the effect of meat production on environmental parameters is much, much clearer. But there are some complexities here, and let me describe a couple of the complexities that we need to sort out. The first, and this is when I'm aware I'm speaking to people who probably, well, who definitely have hugely greater expertise than me, is that if we take cattle, then cattle produce a huge amount of methane. So methane is deep water rice and cattle, the two main sources of methane. And methane, of course, is a much more powerful greenhouse gas than carbon dioxide, but its residence time in the environment is a couple of decades, compared with essentially forever for carbon dioxide, forever from our lifetimes, from a policy point of view. So some of the statistics that have, so we know that the greenhouse gases produced by cattle are a really significant thing that we have to do something about. But we have to get it right with understanding the complexities of these different species of gas that are produced. And let me give you an example. So typically at the moment, we use something called the greenhouse gas warming potential. And if you do this, forgive me, these are rather small. This is grass-fed cattle, and this is grain-fed cattle here. And if you just look at the mean, which is the cross, these are medians here, then using the traditional metric, grass-fed comes out as worse than grain-fed. But if you use an alternative, and I'm not actually saying this is the right alternative, but something that looks at the cumulative warming effect of these gases on the environment over 100 years, then that can be reversed. Now, I'm actually not trying to make an argument here that grain-fed is better than grass-fed or vice versa. The argument I'm trying to make here is we need a better understanding of exactly of the dynamics of these different gases. And it actually is complex because it matters what your policy goal is as well. If you're trying to do something short-term or if you're trying to do something long-term. And it matters because what you do in agricultural greenhouse gas emissions is also related to what you do with total greenhouse gas emissions throughout the different sectors. So that's one of the complexities around the multiple emissions of different greenhouse gases. Another issue is the contested evidence base about, in particular, pasture land to soak up carbon dioxide. And my colleague at Oxford, Tara Garnett, has done what I think is a really nice and authoritative discussion about some of these issues. And she called it grazed and confused, just because there is so much misinformation out there. And you have some quite extraordinary claims about the amount of carbon dioxide that can be sequestered in pasture land. Some sort of non-peer reviewed by advocacy groups like the Savory Institute, but even within the academia, even within academic research, really some quite different estimates. So we have to try and sort that out. And then I was talking largely there about livestock production and greenhouse gases, but that's not the only effect that livestock has on the environment. And this is some work we've been involved with a group in China that was published actually only a couple of weeks back, which is looking at nitrogen pollution of rivers in China. And essentially the whole of the east coast, well, the eastern part of China, the amount of nitrogen in freshwater bodies is enormous. So China has actually a nitrogen threshold, which they're trying to aim at. And that was breached in the 1980s. And now it's getting on to 2.5 times greater. And it is a priority of the government to try and reverse that. Now, that blue bar there is the contribution of livestock to the nitrogen in freshwater bodies in China. The green up there is nitrogen fertilizer runoff from agriculture. Interestingly, these groups here are, that's organic garbage, and this is human waste here. And again, the argument we were making in these papers is how one can move more towards a circular economy, how one can do some of the recycling so that actually you're not sort of wasting the nitrogen and getting it out into the environment there, and you can use that to substitute for some of the nitrogen being put on the environment. So forgive me, that's just a bit of research I'm quite keen on as it's just come out. In this section, I'm going to go back to our modeling and to do something which is a little bit crass, and forgive me for that, and that is to ask, what if we tax climate-unfriendly foods? And that's a little bit of the methodology there. We use life cycle analysis. We introduce a proportionate tax to the amount of carbon dioxide produced, and then look for perverse effects. And again, I underline, this is really a simplistic first look at such a problem. Now, what effect does that have on price if you were to do that? And some types of food would increase quite dramatically in price. So this is a global average, but you'd expect prices of, for example, beef to go up by 40%. Just going there's oil, milk, lamb, and then you're coming down here to some of the vegetable approaches. So again, this is quite a big change in food prices. Now, what difference would that have on consumption? Well, it depends then on what the economists call the elasticities. And with our assumptions, then you get a reduction of around about 15% for beef and so on. So again, this is, I would see this as a thought experiment rather than a policy prescription. What's the underlying message if you do that? Well, if you made those changes, which would reduce the meat in the diet, it would sort of, if you're not eating meat, you have to eat something else. So your vegetable, grains, and fiber goes up. And what you get is you actually get another one of these sort of double benefits. You get a benefit in terms of avoided deaths, which in our calculation there is about 100K. I've deliberately blanked this out for the moment. And you get a gigatons less CO2 going into the environment. Now, what does that mean? I have to say it doesn't mean much to me, but it's about a 10% of what we need to do to keep the global temperatures below 2 degrees, what the Paris Accord has set as a target. So again, completely understand this is politically completely outside the narrative at the moment, but were one to do a food tax, if you accept the model, then it does make quite a big difference. 10% of what one has to do, and you get this health benefit. Now, the reason I blanked out the map is that there are some really that sounds just good, but if you look at the hot colors there, that is where deaths go up. So you've made, and again, it's simplistic, you've assumed a global tax, and so deaths have gone up here, and that's unconscionable. It's ethically horrible to think that in order to bring greenhouse gases down, we're causing increased deaths there. But what you can do is you can then say, well, let's have special, what WTO will call special measures for these countries there. So for a relatively small change, remember we had 1 gigaton of CO2 benefit before. If we gave up 10% of that, so it's still really a pretty good benefit, instead of having 100K avoided deaths, we have 500K avoided deaths. Now, this is a bit of an academic exercise to explore what a meat tax would mean, but I think the issue, I would say, is that this does mean we need to think radically about things like this, again, if we are serious about feeding the world and feeding the world sustainably. But it does come into this issue of meat and political equity. What I worry about taxes such as that is, you know, I'm a middle-class Brit. My salary is such that if I really like meat, I could afford it. If I was in the lowest decile of the income stream, I couldn't afford it. So that's what worries me about tax. So these issues of meat and political equity, we have to be much more straightforward about. That's the distribution of cattle around the world. There are India is sort of, again, as you know, it's largely for dairy there, but a lot of the really poorest people in the world rely on cattle for both food and income and many other things. We have to have such a nuanced debate about when we talk about what we may need to do in the rich world and what we may need to do in the developing world. Now, you may have guessed that I'm not a great fan of Brexit, but the one interesting thing that has happened about Brexit is that we are exploring what might happen if we left the Common Agricultural Policy, which is our equivalent of the Farm Bill, how we maintain rural incomes. And one of the big challenges in the UK, this is in the Lake Districts, northwest England, is how you maintain a vibrant rural economy in these areas. And at the moment, this sheep farming is subsidized hugely. And there's a really interesting argument, discussion at the moment. This is a government white paper that's come out about how there might be alternative income streams for livestock farmers in high-income countries. And the mantra around there is public money for public goods. What are the ecosystem services that these farmers are providing? Yes, they're providing some private goods through producing lamb, but they're providing sites for biodiversity, sites for recreation. They're not really locking up much carbon, but if you've got the incentives right, then they could lock up considerably more carbon. So I think there's some really interesting debates that we need to have about how one can bring in the livestock industry. We're not going to be able to approach any of these questions successfully if we get a polarized debate with the industry on one side and environmentalists on the other. And of course, there's complex political issues on this side of the Atlantic as well as my side. So the final thing I want to mention is some of the issues around meat alternatives. If I was giving this talk 3 years ago, I don't think I would have brought up meat alternatives. The amount of money that is going into meat alternatives at the moment is really quite substantial. Some of the big companies, Tyson Foods and a couple of the other big ones, are now buying into Impossible Burgers, Memphis Meats, and things like this. You'll have probably seen that Impossible Burgers now has a contract with Burger King, I think it is, to put their plant-based burgers on Burger King menus. We did a project for the World Economic Forum that was launched at Davos in February, looking at some of the issues from them. It's interesting, it's quite the Wild West out there. You hear some extraordinary claims about the greenhouse gas efficiency, for example, of cultured meat. Now, our estimates, this is sort of just emissions intensity for beef at the moment, our estimates at the moment for cultured meat aren't that much better than ordinary beef. But there is a tremendous, I think, capacity to push this down. And it's interested in even mycoprotein, the fungus-based protein, is worse than sort of chicken produced in normal ways at the moment, or pork. So some really interesting capacity for improvement there. There are some really interesting complexities. I'm not going to spend much on this, but this is some work from Oxford from John Lynch, who if you imagine here that we eat meat into the future, and you look at the potential cumulative warming of all the meat we eat from now for the next 1,000 years. Now, I know this is a bit silly, but here we have Midwestern produced beef, Brazilian produced beef, Swedish produced beef, and for these production systems here, the cumulative warming potential in the future begins to plateau, and that is the effect of methane. Because if you're eating the same amount of meat year on year, then you're putting methane into the atmosphere, but it's coming out quite fast. Now, a lot of the cultured meat actually isn't producing methane, it's producing carbon dioxide. And so depending how you do it, if you were to produce cultured meat in the way you produce it at the moment, actually, this is slightly academic because we're talking about 100 years in the future, actually the effects of cultured meat would be worse. Now, of course, what we're hoping is that cultured meat will be produced in these ways, such as here, where the effect wouldn't be as bad. But again, I think the point here is going back to the difference between methane and carbon dioxide. There's some subtle issues here that we need to look at. Some of the social scientists who work with us have been doing some really interesting work, sort of taking huge amounts of data off Twitter, Facebook, Instagram, and things, and then applying quantitative methods to try and look at the different narratives in favor of meat substitutes. And I won't go through all of these in detail, but foods containing alternative proteins help you live a healthier life. So you then sort of take these different ideas and you find they cluster in these different narratives here. And what our research tends to suggest is the thing that, and I should say this is UK data, the thing that is driving people, at least those who are active on the internet, to eat more alternative proteins is the animal welfare issue. It's the alternative proteins do not harm animals. And that is trumping environment, it's trumping health. So again, looking ahead, looking at millennials, animal welfare is a big thing. These are the cautionary narratives, the people arguing against meat substitutes. And again, you can do the same techniques as that. And the one that turns out to be having the most traction is that alternative protein products are not real food. And this is a sort of movement, and again, particularly among millennials, for food authenticity. So we're going to see playing out over the next sort of decades these sort of competing narratives within the social sphere. You know, what is authentic about food? What is good about food? How important is animal welfare? So this is my final slide in conclusions. And sort of starting with some of the bigger pictures, I don't need to tell you this. The food system is entering, oh, that's my, I gave myself an alarm and I don't know how to turn it off. Thanks. But I'm on the last slide. Food system is entering in uncharted waters. So business as usual is not an option. I think action is needed on all fronts. We have to talk about diet. We have to talk about increasing productivity. We have to talk about waste. And something I said very little about, one has to think about the dynamics of the globalized food system. We need to have a difficult conversations about the sustainability of livestock. And industry has to be part of the solution. We must not let this get polarized. And finally, and I always have this in because often I'm talking to different audiences from you. You're imbued in food and you know this issue. But if I'm talking to people who care about biodiversity, about human rights in Asia and things like that, then I do try and remind them, you know, if we fail on food, whatever you care about goes out the window. If we fail on food, we fail on everything. Thank you very much for your attention.
Dr. Godfray's talk is open for discussion. We have 7 or 8 minutes, so anybody want to raise sometimes controversial issues brought up. I wanted to ask you, so you talked about the WHO diet. What is that in 2050? How much difference is that from what we now have?
It's eating less, so getting your calories right. And of course, as you know, then getting your calories right actually goes a very long way to a healthy diet. And then it's having a pretty diverse set of food types. So not too much fat, not too much sugar, a lot of fiber. So it's nothing particularly that you wouldn't recognize. It's similar to your guidelines in the States.
Yes, that's going to be a big issue. The committee has just been established for the U.S. dietary guidelines, and they're going to have to deal with, I presume, because they did the last issue, the issue of sustainability. And it's going to be interesting to see what develops.
I'm aware of some of the politics over here. The WHO doesn't take into account sustainability, so it's purely a health issue. That is purely health, and of course it's a contentious and political issue whether WHO should also take into account sustainability.
Please.
I really appreciate your talk. One of the things that came up as a little bit of a theme in our 2015 summit, I think came through to me at least as well. And as part of that is kind of this disconnect that we have within some of our animal science, animal nutrition community with that of the human nutrition community. You know, and we live in silos, so to speak, and it's a global issue. I'm curious if there's examples of dialogue that you have from England that could help us look at different models on how we could facilitate that particular discussion across disciplines.
Well, I'm afraid that the short answer is no, and this is an issue that even in the few conversations I had with Don and Merlin over dinner last night and beforehand, really strikes me as an issue. I'm afraid my university is part of the problem because we have really strong human nutrition and we have, I think, essentially no animal nutrition. And certainly my human nutrition colleagues who are sort of using the very best statistical methods to get information out of longitudinal studies would be very jealous of some of the things that you're able to do with animals, where you can sort of do experiments with diets and things. And of course, the issue is how much you can transfer from one species to another. But no, I mean, the answer is no, but it's a really important point there, and there should be more discussion on that.
Thanks for your talk. I thought it was really interesting and really raised a lot of really good points. So the one I wanted to ask you about is there's kind of a dichotomy between, you have that comment about technology and the need for it to be adopted to achieve some of successes here. But on the other hand, we have a public that seems to not like technology, that's sort of reflected in that slide that says it's not real food. You know, these things become marketing claims, and then technologies that increase sustainability seems to go away. So what do you think is the future of public acceptance of technology?
Yeah, within the UK and within agricultural research policy worlds, there has been a slightly unfortunate equation of technology with high tech, and actually often plant breeding and often genetic manipulation. Largely because, I mean, these are brilliant people, but there's a very good caucus out there who's trying to say that. Now, going back to my days as a good old entomologist and things, within the UK, we're losing skills in entomology, in agronomy, and soil sciences. So my argument is that we need to have investment across the board in agricultural research, that we shouldn't, and I think it's different in the States, but if you look in the UK and Europe more generally, we have perhaps put too many eggs in one basket and haven't brought the public with us. I think one of the big issues in the UK is gene editing. well, not only in the UK, will gene editing be better breeding or will it be GM? At the moment, I think on my side of the Atlantic, it's more GM, and this side, it's sort of more marker-assisted breeding, that type of stuff. A year ago, actually, I no longer hold professor of entomology. I now have a new job. I'm actually in the social science. I'm actually in the social science division in Oxford in running this program. My community, the natural scientists, we need to learn more about social sciences. We need to learn more about how change happens, and we need to be more adept at communicating what we do to a broader audience.
To follow up on that, you've given us some ideas about how to move forward with research in social science and to address the technology questions. Could you speculate a little bit about what types of activities might be beneficial to pursue with regard to engaging industry and the conversation between the environmental community and industry?
Yeah, I think, and I speak with some humility here because I know there are people from industry in the room, but I think industry is going through its own transition at the moment. I've spoken to very senior people from major meat processing companies who just get it and know things are changing and are trying to position their industry on the right side of what are going to be global change, who look to the oil industry and looking at companies now which, so if you look at the big oil companies, then companies like Shell and Statoil are seeing themselves as energy companies. Exxon is still struggling and trying to sort of be ahead of the curve and avoid some of the mistakes that energy made. Some still find it really hard. I won't mention the company, but a big European meat company circling the wagons and just sort of putting their PR. Someone said to me, you can always tell industry by who they send. So some companies will have a bespoke unit sort of trying to look at these things. Others will send their PRs, and you know that you're in problems when you get to the companies that send their lawyer.
Well, okay, go ahead, Mike.
So I'm curious, when you look at the global impact on emissions for the dairy industry, what numbers do you use? Because we have a lot of cattle. I want to be culturally sensitive here, but we have 300 million cattle in India that you assign to dairy, and most of them are not very productive. And if we were clearly interested only in dairy for those cattle, we could have a lot fewer of them and produce a lot less greenhouse gas. I guess how do you deal with that? And in the big picture, are there things we could do in India to perhaps have fewer cattle and get the same amount of milk?
I would have to check exactly what our sources are. We tend to use the sort of major LCA surveys and things, so I can find that information for you. The issue around India is really fascinating. Exactly what you say. I mean, there is a lot of methane being produced there. I mean, again, as you'll know, some Indian dairy is some of the most efficient in the world, but a huge amount isn't. President Modi is up for election anytime now. I can't remember exactly when it is. The whole issue around cattle and Hindu nationalism has become a hugely complex political topic. Again, livestock production, it sort of goes over into the political sphere in India in a way that we just don't realize in other countries. So conversations that you have around that topic are hugely politically sensitive.
We need to move on to the next presentation. Thank you for a very nice stimulation, getting us started with our conference today, Dr. Godfray. Thank you so much.